Now, suppose you are given a quadratic expression. Say ax squared plus bx plus c is a quadratic expression. Ax squared plus bx plus c is a quadratic expression, just an expression, right? Now, you want to factorize this expression. Suppose you want to factorize this expression. All right. And you have figured out, let's say, by some means, that this expression becomes 0 at x equal to alpha and at x equal to beta. Suppose this expression becomes 0 at x equal to alpha and at x equal to beta. Now, if an expression becomes 0 at a certain value of x, for example, if you look at this, x square minus 1 is an expression, right? X square minus 1 is an expression. And you find that this expression is becoming 0 at x equal to 1 and at x equal to minus 1. Very clearly, if this expression becomes 0 at x equal to 1, then x minus 1 must be a factor of this expression. If it becomes 0 at x equal to minus 1, then x plus 1 must be a factor of this expression. Yes or no? So, in a very general sense, if an expression becomes 0 at x equal to alpha and at x equal to beta, then x minus alpha must be a factor of that expression, and x minus beta must also be a factor of that expression. Yes or no? So, if this expression is found to vanish at x equal to alpha and at x equal to beta. Suppose this expression is found to vanish at x equal to alpha and at x equal to beta, then x minus alpha and x minus beta must be factors of this expression. That means, in your attempt to factorize this, if you have found values of x for which this vanishes, then you know that x minus alpha and x minus beta must be factors of that expression. That means, this expression, when sought to factorize, will certainly have factors x minus alpha and x minus beta. Yes or no? Now, when you factorize an expression, what are you creating? For example, if you are factorizing x square minus 1, then you are creating an identity. Factorizing an expression is like creating an identity. So, a bid to factorize this is equivalent to finding an identity, That means this expression must be identical to this expression. So, one thing for sure, that this expression has these two as its factors made available. Now, if this has to be identical to this, coefficient of x square here is a, coefficient of x square here must also be a. But do you realize x into x, x square, coefficient of x square right now in this form is only 1. So what you want to do is you multiply by a and cause the coefficient of x square to become a, isn't it? Now the coefficient of x square has become a. Coefficient of x square on the left hand side is already a. Now this then could be used as an identity. This then could be used as an identity. Now, having said this, what we could do is, since a is not 0, assuming a is not 0, other coefficients could be 0, but in a quadratic expression, a should not be 0. If a is not 0, you could then divide by a. On dividing both sides by a, you get x square plus b by a into x plus c by a equal to x minus alpha into x minus beta. Yes or no? Right? Now, when I multiply this out, I get, again, left hand side remains the same, x square plus b by a into x plus c by a. And this formation is not an equation, it's an identity, mind you, is x square minus alpha x minus beta x, isn't it? X into x, x square minus alpha x minus beta x is like minus alpha plus beta into x plus alpha beta. Yes or no? Right? So this is identical to this. If two expressions are identical, then coefficient of equal powers of x in the two expressions must be the same. That means if this expression is identical to this expression, that means if this formation is an identity, then coefficient of x square 1 on the left hand side, coefficient of x square 1 on the right hand side. Coefficient of x on the left hand side b by a, coefficient of x on the right hand side minus of alpha plus beta, which would give me sum of the roots alpha plus beta as minus b by a, right? The term independent of x on the left hand side c by a, the term independent of x on the right hand side alpha beta, which would give me alpha beta equal to c by a. So that's another way of obtaining the sum and product of the roots of a quadratic. That's another way of obtaining sum and product of the roots of a quadratic. Yes or no? Right? Do you understand this? Right? Now, suppose somebody gave to you the roots of a quadratic, isn't it? Suppose alpha and beta were the roots of a quadratic. Instead of giving you the quadratic, somebody gave you the roots of a quadratic. Suppose alpha beta were the roots of a quadratic. Then he said, find the quadratic. He said, find the quadratic. Now, do you realize that x minus alpha into x minus beta is a statement, is an equation. X minus alpha into x minus beta equal to 0 is a statement. And it boils down to an equation. It's an equation. It's an equation, right? And this left hand side will become equal to 0 at x equal to alpha and at x equal to beta. Which means this is a statement which is true for x equal to alpha and for x equal to beta. That means alpha and beta are the roots of this equation. Alpha and beta are the roots of this equation. Why? Because at x equal to alpha, this becomes 0. At x equal to beta, this expression becomes 0. Therefore, alpha and beta are the roots of this equation. Yes or no? Which means now on multiplying. So this is an equation whose roots are alpha and beta. Now on multiplying, you get x squared minus alpha plus beta into x plus alpha beta equal to 0. This is what you get. X square minus alpha plus beta into x plus alpha beta equal to 0, which is a quadratic in x. And this is satisfied by x equal to alpha and x equal to beta. This then, since it's satisfied by x equal to alpha and by x equal to beta, is a quadratic whose roots is a quadratic equation with roots alpha and beta, with roots alpha and beta. So which means a quadratic whose roots are alpha and beta could be obtained as x square minus sum of the roots. Alpha plus beta is sum of the roots into x plus product of the roots equal to 0. That means a quadratic whose sum of the roots is known, whose product of the roots is known, is x square minus sum of the roots into x plus product of the roots equal to 0. For example, if someone said sum of the roots of a quadratic is 5 and the product of the roots of the quadratic is minus 1, suppose. Find the quadratic in which the sum of the roots is 5 and whose product of the roots is minus 1. What would we do? We'll say x square minus sum of the roots, which is 5, into x plus product of the roots, which is minus 1, equal to 0, is a quadratic whose sum of the roots is 5 and product of the roots is minus 1. This then brings you to a point where given the roots, or given the sum of the roots and product of the roots, given the sum of the roots and the product of the roots, you can find the quadratic. What is a quadratic? The quadratic is x square minus sum of the roots into x plus product of the roots equal to 0. That's the quadratic given the sum of the roots and product of the roots. Thank you very much.